Hi, Janet. Well, clearly we see this answer, or we see this problem, and I've already worked out this answer. But just to review with you exactly what we did, you already did it in your calculator. I do want to, I don't know, harp on the idea of writing some things down just so that you can remember them, but just in case, you don't want to do that, we've got this opportunity right here if it will ever open up for me. At any rate, you know to find the midpoints of everything in that frequency distribution. Ooh, thank goodness I can close that and get that out of my way. And you've done all your calculations. And it tells you to use the class limits of 66 to 75 for the over 65 group. So that means that the midpoint of this guy would be 60.5, that you would multiply times that 4. So, of course, you've got your ages. I'll call it a big A for age. No, I'll just write it out. Age. And then we've got our frequencies. And I'm going to go ahead and write down the midpoints for each one of these. So this first midpoint is 20.5, and they're all going to be the same. They're all 10 away. So 20.5, 30.5, 40.5, 50.5, 60.5, and 70.5. That's all we got here. It won't take me too long to write these down, but we shall see. I'm an old lady. All right, and 70.5 for the last group, over 65. And our frequency is, of course, as you see in the picture, 13, 61, 66, 37, 13, and 4. And if we were to try to see if this is normal, let's think about this. So we've got like 13, and then we've got like 61, and then 66, and then 37, and then 13 again, and then 4. So if we were to make like a little quick old histogram of, our data, it looks like it's kind of normal. I mean, it's not exactly normal, but it's normal enough for our mean. There's not a strict normality constraint here like there is for the standard deviation. All right, so that's the frequency. So we add up all these guys and we get 194. So that's the total number that we have, is 194, which would make our degrees of freedom 193, n minus 1. 193. That's our degrees of freedom. And if we look at the table that I gave you, we don't have no 193 row on this table, so we've got to use StatCrunch. Now, in order to use StatCrunch, let me come over here, and I'm going to have to jump inside some class and actually put this data in it. So I'm just going to click here and pretend to watch these videos, but I definitely encourage you to watch them. They are very good. Those professors are top notch. Now, I'm going to click on question 9, which is what this question is similar to, I think. You said it was question 9? All right, and then I'm going to go down here to get more help and go to StatCrunch. Now, within StatCrunch, what we're going to do, because they did not tell us anything other than that this is a frequency distribution, so we have to figure out the standard deviation. So we go to Stat, and we go to T-Stats, and we go to one sample, and we say with summary. This is where we go. But anyway, let me get back to my calculations here, because all I know right now is how many I have. Now, when I do the X bar, I have to take these midpoints and I got to multiply them times the frequency and then divide by this total number here. So let me do it again. The sum of my age times my frequency, each one of my ages, multiplied times the frequency. And this summation means add them all up, divided by the sum of all my frequencies. And that gives me a mean of 39.9. Take your time and see if you get that mean. If you don't, I'll come back and calculate that with you, but that'll take a little bit more time. And I don't have a whole lot with this little video program I'm using. All right, now for S. The formula for S is a little bit more complicated, and it was written down a long time ago from chapter 3. But you take the total number, and you're going to multiply it times the sum of your frequency times each of your midpoints squared. Oh, snap. So 194 times the sum of this frequency times this age squared, or the midpoint of that age, minus the midpoint times the frequency, the sum of all of that, all of that gets to be, whatever that sum is, squared. So let me go back up here. This number that you got right up here is the same number that goes, and this top number is the same number that goes right there that you square. Same number. And then on the bottom, I know you like, we ain't done yet. No, on the bottom you got n times n minus 1. This is the formula that this book says is the easiest. There's another one and it's uglier than this. So we'll just go with this one. And when we plug all that in, we find that the standard deviation is 11.1. I hope that you got that for your standard deviation. Now, because our table does not have a degree of freedom that includes 193, we got to use the technology. So we come over here and we put in our mean, which is 39.9, and then our standard deviation, which is 11.1, and our sample size, which is 194. And then what do we want to perform? We haven't done hypothesis testing yet, but it's coming next week, and we're going to do the confidence interval, and the interval is a 99% confidence interval. And then we go ahead and hit compute, and it gives us our interval. Our interval goes from, if I'm not mistaken, 37.8 to 41.97, and they wanted to round it to one decimal place, so it would be 42. So that is why our answer to this question is exactly what I showed you a moment ago. Good luck with that one.